Okay, so let's move on to the eighth property, which is differentiation in frequency domain. Okay, so as usual, let us take x of t has x of j omega as the Fourier transform. Okay, then t times x of t will have j times d by d omega of x of j omega as the Fourier transform. So what does that it mean? If you multiply the signal x of t with the t, that translates to differentiation in frequency domain. Note that j will come into the picture. Okay, so let us prove this. It is one step proof. So we take the analysis equation, which is given by x of j omega equal to integral minus infinity to infinity x of t e power minus j omega t dt. Now let us differentiate this. So let us see what happens. Okay, so d by d omega of x of j omega would be equal to integral minus infinity to infinity x of t. Why you are differentiating with respect to omega? There is no omega term here. So this we have omega term. So you will get differentiation with respect to omega will give you minus jt e power minus j omega t dt. Okay, now let us multiply throughout with j. So you will get what? J times d by d omega of x of j omega would be equal to integral minus infinity to infinity t x of t multiplied with e power minus j omega t dt. So this implies what? So this is looking like what here? This is looking like Fourier transform of which signal? Tx of t. So Fourier transform of Tx of t is given by j times d by d omega of x of j omega. So that completes the proof. Okay. So we will take a few examples. Let us take first example. Okay. So given x of t equal to e power minus a t u of t with Fourier transform x of j omega equal to 1 by a plus j omega. Okay, so find Fourier transform. Okay, so find CTFT of, let us take first signal to be t times x of t, which is equal to t times e power minus a t u of t. So we want Fourier transform of which signal? T into e power minus a t u of t. So this fellow will have j times d by d omega of x of j omega, which would be equal to j times d by d omega of, what is x of j omega here? 1 by a plus j omega. So this will give you what as the answer. We'll do the differentiation. So you will get j times, correct? So that is multiplied with, so you'll get minus 1 by a plus j omega whole square, and again this whole thing is multiplied with j. Why? You have to again differentiate a plus j omega, you'll get j here. So this simplifies to how much? So j into j is minus 1, minus 1 into minus 1 is plus 1. So you will get 1 by a plus j omega whole square. So what did we get? T times e power minus a t u of t. Okay, so this fellow will have 1 by a plus j omega whole square as the Fourier transform. Next, let us take second example, which is t square e power minus a t u of t. Okay, so we want to find the Fourier transform of this signal. Okay, but this can be written as t times e power minus a t u of t, correct? And how is this looking again here? This is looking like t times x1 of t, which is, so this is t times x1 of t, correct? So what will be the corresponding Fourier transform? D by d omega of x1 of j omega. But what is x1 of j omega? Because x1 of j omega is Fourier transform of x1 of t, but what is x1 of t? T e power minus a t u of t. So for that we already know the answer to be how much? 1 by a plus j omega whole square. So this should be equal to j times d by d omega of 1 by a plus j omega whole square. So you can simplify this to get, so this should be equal to 2 by a squared, sorry, 2 by a plus j omega whole cube. Okay, you'll get 2 by a plus j omega whole cube, and going on in this way. So what would be the third one? I mean, what would be the Fourier transform of t cube? E power minus at u of t. So I will leave that as homework, but you should get 6 divided by a plus j omega whole power 4. So now you should see a pattern. Okay, so proceeding in this form. Okay, so I'll write down that. So proceeding in this way. Okay, so proceeding in this way, what do we get? We get t power n e power minus a t u of t will have what as Fourier transform. Note that if you have 3, you are getting 6, which is nothing but 3 factorial. If you have n, you should have n factorial divided by a plus j omega whole power. If you have 3, you should have 4. So if you have n, you should have n plus 1. So Fourier transform of t power n times e power minus a t u of t will have n factorial divided by a plus j omega whole power n plus 1. Okay, right. So we'll take one more example. So previous problem is important. So especially what is the general result also is important. So t power n e power minus a t u of t will have n factorial by a plus j omega whole power n plus 1. What happens if n equal to 1, which is a special case? So that is t times e power minus a t u of t. So that fellow will have 1 by a plus j omega whole square. That we have already seen before. Okay,